Good morning to everyone. I am S. Kudasegaran, working as assistant professor in the Department of Computer Science Engineering. Today I will discuss about Internet protocol. Two types of addressing in Internet protocol. One is for IPv4 and one is IPv6 addressing. So first discuss IPv4 addressing. So this IP corresponds to network layer in the OSI reference models. So in networking, OSI reference model having 7 different types of layers. That one type of layer is a network layer. So the IPs correspond to network layer in OSI models. Then Internet protocol have a fixed length of 32 bits. So the total size is 32 bits only. So any IP address we can using in these 32 bits. Then two devices on the internet can never have the same address at the same time. So each devices we can use only one IP address. Then only we can transfer the data from one device to another devices. So the same IP address cannot use in two or more than devices. The next two level of hierarchies we can using IP. So one is for network IDs, another one is a host ID. So network IDs that identify the network to the host is connected. Then host ID identify the network connections on the host. Then what is used for IP usages? So this IP mainly we can use it to connect one device to another devices. Then we can transfer the file from one device to another devices. These things we can use in IP. Then IP structure. So IP structures based on two types. One is for classful address and one is a classless addressing. So now classful addressing IP structure discuss. See in classful address the structure is divided into 5 address classes. That is class A, class B, C, D and E. Then class E mainly we can using reserved for government agencies. Then class B, class C reserved for private sectors. So private sector means that is using any educational institution and any companies. Then class D reserved for multicasting. That is multicasting means we can map one-to-one mapping or one-to-many mapping concept we can apply in class D. Class C mainly we can using for feature use. So these 5 classes we can using in classful address. This basic address spaces in classful addressing. So each classes we can occupy some space. Class A occupy for 50% and class B is 25%, class C 12.5 and D and E 6.25. And class A we can using 8 bits. 8 bits that is 1 byte. First byte we can using for 3 bits. Remaining 3 bytes are suffix. So already discussed about the IP address length is 32 bits only. So here we can using totally 32 bits, that each 8 bits divided into 1 byte. So class A occupy 1 byte, that is a prefix, remaining are suffix. Then class B 2 bytes using occupy prefix and 2 byte occupy by suffix. And class C 3 bytes occupy prefix and 1 byte suffix. Class D is a multi-cut address and class E is a reserved for feature users. Based on these classes we can use the ranges of values. The class A we can use 0 to 127 and class B 128 to 191, class C 190 to 223, class D 224 to 339, class E 240 to 255. Based on these ranges we can allocate the classes in IP address. Then two notations mainly we can using for IP address. One is for dotted decimal notation, another is a binary notation. So dotted decimal notation we can use the values, that is 0 to 255, that is based on IP address values. Then binary notation we can using for zeros or ones. So these two notation mainly we can using for IP. The next IP header format. The header format based on IP length, that is for totally 32 bit length. So first we can using for version VER is a version, HL header length, service type and total length, datagram identification, flags, fragment offsets, time to line, protocol, checksums, source IP address and destination IP address. So this basic IP header format, each one explained. First VER is a IP protocol version. The version we can mainly using IPv4 or IPv6. Then HLN is a header length, that is length of the IP header using for 32 bits. Then service types, the quality of services requested per IP datagram. The total length of the IP. Then packets in the IPv4 layers are called datagram. So here packets means each data is divided into small font. That small font is a packets. Then we can identify unique numbers, center used for fragmentation. Then flags identify packet fragmentation. The fragment offsets, this is the attribute position of the fragment. Then time to live, the number of router connected to COF. Then protocols in IP, we can using mainly TCP protocols, UDP and ICMP protocols. Then header checksums to check errors for in IP address. Source IP address to identify the source address of receiver or centers. Destination IP address to identify destination address of source or centers. So this based on header format in IPv4. Thank you.